Monitoring a Docker cluster. In this section, we'll learn how to monitor a Docker cluster. First, we'll cover the ELK stack. You'll learn how to install it and how to use Kibana to view logs and create dashboards. Next, we'll learn how to collect performance data with Prometheus. We'll then see how to create charts of that data using Grafana. We'll then learn how to use sysdig to monitor individual hosts and containers in real time. Finally, we'll discuss other things that you should be aware of as you consider monitoring your Docker cluster. Installing the ELK stack. In this video, we'll learn how to enable Elasticsearch logging in Kubernetes. We'll start with an introduction to the ELK stack. We'll then install Elasticsearch. The next steps will be to enable FluentD and Cabana to collect logs and view them. The ELK stack is a collection of software tools that provides a central point for collecting logging information. The name comes from the three tools that make up the stack: Elasticsearch, Logstash, and Kibana. Elasticsearch is a NoSQL-style database that can be used by a variety of applications. It is very fast and was designed from the beginning to be able to operate in a master-master environment. Logstash is a tool which can take logs from a variety of sources and store them in Elasticsearch. Those logs can come in a number of different formats, including syslog and the Graylog extended log format. We won't be using Logstash initially, but we'll see it in more detail in a later video. Kibana provides a web interface into Elasticsearch and makes it possible to pull meaningful information from your logs. You can also build dashboards that show just the logs you want, as well as charts of graphical information. Let's enable Elasticsearch on our Kubernetes cluster. Elasticsearch is fairly heavy. Make sure that your worker nodes have at least 8 GB of RAM. You can install Elasticsearch when you install Kubernetes, or it can be installed later. We'll go through the post-install process so that we can configure it to use a persistent volume. The add-on is available in the Kubernetes source. We can check that out from GitHub. The add-on is in the Kubernetes source directory in /cluster/add-ons/fluentd-elasticsearch. This directory has everything we need to get started. The file es-statefulset.yml contains the configuration for the Elasticsearch service. Scroll down to the Elasticsearch-logging stateful set, and we'll start making changes here. We need to create a volume claim template that uses a storage class to dynamically create the volumes that Elasticsearch will use to store the incoming logs. The default specification uses an empty dir volume type. That's great for testing, but the data stored in the volume is deleted when the pod is deleted. Let's go ahead and comment that out. You can also enable XPact in Elasticsearch, which provides additional authentication options. I'm going to leave it at the defaults to simplify the examples. See the documentation for the add-on in Elasticsearch if you want to enable it. Now that we've changed the volumes to something a little more permanent, let's create the stateful set and the service. Let's use kubectl-get to see what happened. Oh, there's no stateful set. These specifications use the kube-system namespace. To see them, we have to use the -n flag to set the namespace to kube-system. And there's the stateful set for Elasticsearch. The Kubernetes add-on uses FluentD to gather the logs and send them to Elasticsearch. FluentD cannot run on Kubernetes masters. For it to work, you need to tag every worker node with the label beta.kubernetes.io/fluentd-ds-ready equals true. This is done with the command kubectl label nodes. My worker nodes are kube2 and kube3. Before we create the FluentD service, we need to add the configuration to Kubernetes as a config map. We'll use the default configuration. If you enable XPact, you need to configure that here in fluentd-es-configmap.yaml. Now we can create the FluentD daemon set. We can check the FluentD daemon set and see that there are 2 pods running, one for each worker node. If a new node is added and the fluentd-ds-ready label is applied, a new FluentD pod will be started there as well. With FluentD running, logs generated by pods running on the cluster will be sent to Elasticsearch. Now we can start Kibana to see the logs. We'll start with the deployment. If you enabled XPact in Elasticsearch, you'll have to add it to the Kibana configuration in Kibana-deployment.yaml. We need to create the service as well. Now that all the services have been created, let's take a look at the cluster information with kubectl cluster-info. We can see two new services, Elasticsearch and Cabana. If you properly authenticate to Kubernetes, you can use those addresses directly. The easiest way to do this, though, is to use kubectl proxy to authenticate and provide the connection. This makes Kubernetes web services and APIs available on the port specified with the -- port flag, in this case, 8080. When you first load Kibana, you will be asked to choose an index pattern and a time filter field. The index pattern should be log/* and the time filter field should be @timestamp. In this video, we learned how to enable Elasticsearch logging in Kubernetes. We started with an introduction to the ELK stack. Then we installed Elasticsearch. Finally, we enabled FluentD and Cabana to collect logs and view them.